Turn to page 5, find the interval on which x squared e to the x is decreasing. Yeah, there's your challenge problem. We have a function. F of x is x squared e to the x. What's the interval on which this is decreasing? A function is decreasing. One way to indicate that is looking at the first derivative. If the first derivative has negative values, then the function is going downhill. It's decreasing. So what we're going to do is take the derivative of this function according to the product rule. Let's set up the product rule skeleton. And then when video sub comes back, on Monday, Mr. Roy's will wrap up that other question with you, the one on the bottom of the previous page. So let's wrap up the lesson here on page 5 with this guy. Basically, we want to find out when is f prime of x less than 0. For what values of x is the derivative negative? All right, here we go. Product rule. Derivative of the first times the second plus first times the derivative of the second. When is this less than 0? Well, I don't want to talk about that until we factor it. Let's put it in factored form. The greatest common factor appears to be x e to the x. When I factor out the x e to the x, what remains in parentheses is 2 plus x. Alrighty. So my question is, when is this less than 0? Well, to find out when it's less than 0, I'd be interested in seeing some boundary points. The boundary points would be where it's equal to 0. And using the zero product property, yeah. Okay, so using the zero product property, the boundary points can be found by setting x equal to 0, or e to the x equal to 0, or 2 plus x equal to 0. E to the x is never equal to 0. We saw the green graph on page 6. It has no x-intercept. So we can ignore this one. It's going to give us no solutions. There's a boundary value right there at x equals 0. Here's another boundary value at x equals -2. All right, so I'm going to set up a number line with these boundary values. And I'm going to give the number line 3 layers of labeling. Under the number line, I put x, containing the boundary values at 0 and -2. Those are places where the values might change. The second of 3 layers of labeling is right above the number line. I write f prime of x. And above that, I'm going to do this in different colors. So we've got the red layer down below, which is the boundary values. Above that is the blue values for f prime of x. And above that in green, we have the values for f of x. Now, let's take a test number to the far right, like 10. If I put a 10 into the derivative, this is positive, positive, positive. It's going to be positive on the far right. So for the blue value, I'm going to write plus. How about a test number between -2 and 0? I'll take, well actually, I know that since these are odd exponents, that these are going to be odd 0, so it is going to alternate. If you don't believe it, put a -1 in for x, you'll see that this is in fact negative times positive. Yeah, that will be negative, and then this one will be positive, because these are odd boundary points. So if the first derivative is positive, that means f is increasing. So put a little uphill symbol here next to f of x. When the first derivative is negative, that means that f is decreasing. The question was, for what values of x is f decreasing? I think that was the question. Yeah, decreasing. It's decreasing when x is an element of the set -2 to 0. and that's in parentheses. And decreasing, you know what? It's actually in square brackets. I have to give you a formal definition of increasing and decreasing to explain why it would be in square brackets, so that's yet to come. But that's our lesson for today. Assignment number 11 is due on Monday. Thanks for coming. When the bell rings, you're out of here. This has been Video Sub. See you Monday.